In this lesson, you will solve problems involving proportions and also calculate unit rates. A proportion is an equation stating that two ratios or rates are equivalent. In a proportion, the cross products are always equal, meaning if I take these two ratios that are equal to each other, if I multiply diagonally, 8 times 3 is 24, and 6 times 4 is 24. Anytime you have two equal ratios, when you multiply diagonally, you'll get the same thing on both sides. In our first example, it says after 2 hours the air temperature had risen 7 degrees. Write and solve a proportion to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees. Well, you're going to write down the first rate that they give you in the problem, and that is in 2 hours, and I write down the labels so I can keep myself organized. In 2 hours, the temperature had risen 7 degrees. And we want to know how much time, so x hours, will it be to raise an additional 13 degrees? So we're going to say 2 over 7 equals x over 13. And then to solve this, we're going to go ahead and write an equation stating the two cross products that are equal. 7 times x is 7x, and 2 times 13 is 26. So 7x equals 26. And then you're going to divide both sides by 7. So x is going to equal 3 5/7 hours. Or if you write it as a decimal, 26 divided by 7, that is going to work out to be about 3.7 hours. You may want to pause the video and try the next two on your own. X times 10 is 10x, and 9 times 4 is 36, so 10x equals 36. Now divide both sides by 10. X equals 3.6. Now in our next one, 2 times y is 2y, and that's going to equal 34 times 5. 34 times 5 is 170. Now divide both sides by 2, and y equals 85. Now you may be tempted to take some shortcuts with solving proportions like this, but I want you to write your work this way because in our next lesson we're going to solve some algebraic proportions, which will require you to write an equation like this and solve it. So you might as well practice on these easy ones. You can also use proportions to make predictions. So during a blood drive, the ratio of type O donors to non-type O donors was 37 to 43. About how many type O donors would you expect in a group of 300 donors? So type O is 37 to 43 that are not, but we don't want to compare to how many are not. We want to compare to total donors. So if there were 37 with type O and 43 with non-type O, that's a total of 80 people. So 37 had type O out of 80 total, and we want to know how many would have type O out of 300 total donors. So this is the proportion we would set up. Now we'd go ahead and solve it by setting cross products equal to each other. 80 times x is 80x equals 37 times 300. Thirty-seven times 300 is 11,100. Now divide both sides by 80. And we get x is equal to about 138, or actually it works out to be 138.75. But Since we're talking people here, we wouldn't say 138.75 people. We would round that to about 139 people with type O. You may want to try the next one on your own. Recycling 2,000 pounds of paper saves about 17 trees. So I'm going to write down 2,000 pounds saves 17 trees. Write and solve a proportion to determine how many trees you'd expect to save by recycling 5,000 pounds of paper. I'm going to put the 5,000 pounds at the top to line up with my 2,000 pounds. And we want to know how many trees that would be. So 2,000 times x equals 5,000 times 17. 5,000 times 17 is 85,000. Divide both sides by 2,000. And x equals 42.5 trees. Now the second thing that we're going to talk about is unit rates. A rate is just a ratio that compares two quantities with different types of units, such as $5 for 2 pounds or 130 miles in 2 hours. When a rate is simplified so it has a denominator of 1, it's called a unit rate. In other words, a unit rate is figuring out how much for 1. This comes in handy when you're trying to compare prices. You want to be able to figure out what the cost is for one of something, whether it be 1 ounce or 1 can or 1 slice, whatever it is. So when you are comparing, you're comparing the same size, and then you'll be able to tell which is the better buy. For example, a 17-ounce box of cereal for $4.89 or a 21-ounce box for $5.69. If you want to compare these to see which is the better buy, you're going to take the price, $4.89, and divide it by the size, or how many. It's $4.89 for a 17-ounce box. So if we want to find the unit rate, it's dollars per ounce. To figure out how much it would be for 1 ounce, if it's $4.89 for 17 ounces, we're going to take $4.89 and divide it by 17. And that works out to be about, I'm going to put a few decimal places down here because sometimes they're really close and you might have to compare out several decimal places. So 2876, that's probably enough for me to see. It's that much per ounce. Now let's try the other one. 21-ounce box for $5.69. We're going to take $5.69 and divide it by 21 ounces to figure out how much it is for 1 ounce. So $5.69 divided by 21. That works out to be about this, 0.2709 and some more numbers after that. Now if we're comparing it, this is about 29 cents an ounce. This is about 27 cents an ounce. So the better buy is the 21-ounce box for $5.69 because that one is the cheapest unit rate, or the cheapest price per ounce. You may want to stop the video and try the last one on your own. 6 cans of green beans for $1 or 10 cans for $1.95. Well, let's start with 6 cans for $1. That's going to be $1 divided by 6 cans. So 1 divided by 6, that's going to be about a little more than 16 cents, close to 17 cents. The 6 is actually repeating. The 7 that shows up at the end of your calculator is just because it's rounding up to at that place value. So it's 0.16 repeating, or almost 17 cents per can. And now for the other one, $1.95 for 10 cans. So we're going to divide $1.95 by 10. $1.95 divided by 10, that's going to equal about 19.5 cents. Or it actually is 19.5 cents. So it's that much per can. So the better deal is going to be the first one, the 6 cans for $1. That one right there is your better deal because it's cheaper per can.